Hello everyone, I hope you all are doing well. So this side Priya Bhatia, and in this particular video we will continue our machine learning playlist. And if you remember, in the last video I have talked about the explanation, or you can say the mathematical intuition behind the lasso and the ridge regression. I hope that you will be able to understand that part pretty well. So now in this particular video the focus is completely on the implementation part. So if there is someone who is directly coming to watch this video, the major prerequisite, as I am clearly stating here, is to watch the previous video where I have talked about the mathematical intuition, because as I always say that without knowing the mathematical part, or I would say the fundamental of anything, there is not a benefit of doing any sort of implementation. So let's get started and we'll try to understand the implementation of lasso and ridge regression, which is basically a regularization techniques used to avoid the overfitting. So here I am doing the implementation in Google Colab. If you want, you can also do the implementation in Google Colab or in your own local environment as well in the Jupyter Notebook. But what I really like is in the Google Colab is that, it might happen that various students are not able to afford the GPUs based system. So they can easily utilize this runtime type. When you will change, you can change it from none. Initially by default it will be none, so you have to change it from GPU. That's the thing that you have to do whenever you are doing the thing on the Google Colab, right? So let's get started now. And first of all, what we can do is we will try to import all the required packages. So let's try to import all the required libraries, or you can say the packages, which is basically useful to grab the data set. So here, if you will observe, I already have imported one housing based data, and I'll copy this path. And first of all, let me import all the libraries. Import pandas as PD, right? Import numpy as np. Import matplotlib dot pyplot as plt, and import cbone as sns. So here I have imported all the required packages which are required for me to do the implementation. Now let's try to do the next task, is to read the housing dataset file. By the way, this is an open source file which I have taken from the Kaggle platform. So if you want, you can also grab that, or I will share the link of the dataset as well as this collab file in the comment section of the video. You can just refer it there. Okay. So data is equals to pd.read_csv, and here I am just copying the path of my data set. Okay. So in order to just look into the topmost 5 records what we have in the data, so I can say data.head, and you will be able to see that we will be having 21 number of columns: suburb, address, rooms, type, price, method, salary, date, and so on. So if I really want to look into the columns specifically, what are the columns that I have? So I hope everyone knows that the way to get the columns is to use this dot columns method. So here, if you will see, you will be able to get an output as a form of a list where all the columns are written. Now, if you will just clearly observe here, right, there are so many, nan values which are there. I hope everyone can see this. In the price itself, I can see in just topmost 5 records, there are 2 nan values which are there. So what is the next task is? So let's try to understand that how we will be able to see the number of null values. Number of, I would say, nan values in the given data set. Although I have already done this EDA kind of a task, this is what we included in EDA part, right? Exploratory data analysis. And if you remember, I have, created a separate video for the EDA part. So I will not go in very much depth. We'll do very, basic EDA. But if you really want to go in very much depth and you want to see that what are the steps which are required or which we can perform in EDA, I will again attach the link in the description of the video, which you can refer, where a detailed video with respect to EDA, with respect to its mathematical intuition, is already been taught to you, right? I hope this part is clear to everyone. So now how we can check the number of nan values? So data dot is null is a function. So this is null function is basically able to return us the Boolean kind of a value. either true or false. So whenever you will be having an n value, it will return the answer as true. Otherwise, it will return the answer as false. But what I want is, I want a summation with respect to every column, right? For example, with respect to price, how many NaN values are there, right? So if I run this, now you can see that with respect to price, I will be having 7610 null values. With respect to bedroom 2, these many are there, and so on. So you can see that with respect to every particular column that I have, I will be having a NaN values. But before moving towards deleting the NaN values, or doing the optimization on top of this NaN values, I can clearly see that, in order to predict the price value, obviously there are features which are given to me, and with respect to those features, what I really want my model is to predict the price. So I can say that the price is a target value, and this suburb, address, rooms, type, method, seller G, date, and so on, these are the features that I have. So I can say that in a way, in the given original dataset, 20 features are given to me, and one price column is given to me, which is the target value, which I really want to predict. Now, what I observe is that, in order to do the prediction for the price, it's not really necessary to have all the columns to take. So what I'm doing is, I'm taking some useful columns, which I feel is useful. So I'm just directly copying it here, because it will take otherwise too much time for me to record the video. So I just copied it. So I'm considering only these columns as the useful columns, or as the input features, which are basically helpful to predict the outcome as price. Okay. Now, after this, what I can do is, I can say that new data is nothing but is a data which contains only the useful columns. Okay, which contains only the useful columns. So now if I'll just show you the new data dot head. So here you can see that this particular data contains, if I'll just show you the shape of this data. So whatever task now I will do on top of this new data only. Okay. So if I'll just show you the shape of this particular data, so you will be able to get that now I will be having 15 number of, I would say, columns that we have. Initially, if you remember, in the original data that we have, we will be having 21 columns, right? So if I'll just show you the data dot shape, you will be able to see the difference now. So here we will be having 21 number of columns, but I have chosen only 15 number of columns, which I believe is basically useful for the prediction of the price. Because, for example, date is one of the feature, which is not important for me, right, in order to do the prediction. Similarly, there are so many columns which I have, for example, latitude, longitude, which I don't find it necessary to do the prediction of the price. So I have just removed those columns, or I have just not taken those columns. Okay. Now moving ahead, now what we want is, we want to just look into this particular NaN values, which we have here. So now we have to deal with this NaN values. Now I have already again referred, please refer that video of EDA. I have already again give a proper explanation that how we can usually deal with the NaN values. So either we can do the imputation with the mean or median or mode, or given some situations. For example, here the car contains NaN values at 8728. So here the proper thing is that to replace with the 0 value, right? Similarly, there are few features which we can replace with zeros. So what we can do here is, I can simply take those columns which I can replace with a 0 value. For example, property count, distance, bedroom 2. If suppose there is a NaN value in those particular columns, for example, bathroom, bedroom 2, distance, it indicates that there is no as such distance or bedroom or bathroom is there. So I am replacing that values with a 0. Okay. So what I can do is, I can do a very simple thing. I can say new data present inside this columns fill underscore 0. So it will take all those columns. What I want to do is, I want to take this new data, whatever columns I have, underscore fill underscore 0. What I really want to do is, I can use the function called as fill NA, which is responsible to fill all the null values with respect to this particular column set of that we have is with respect to 0. So what will happen here is, if now I will just show you new data dot is null dot sum, what will happen is, you will observe that you will be able to get in a way, with respect to the columns which I have taken, property count, distance, bedroom. So what we have seen that we will be having now 0, 0, 0 NaN. Now we need to deal with the landing size, building area, and the price. Price is the target value, so let's focus it, very later. As of now, just focus on the independent features that we have. For example, land size and a building area. So if I just want to show you the distribution plot of, this particular data, so this plot we can use new data dot, I would say, land size. For this, I want to see the distribution. Let's see what kind of a distribution we will be able to get. So here you can see it's kind of a, I would say, skewed distribution, right? Similarly, if I will just show you the distribution for the building area, right? Again, what you will observe is that it's again kind of a, I believe, skewed distribution we will be able to get. So with what particular value we should replace if we will be able to have a skewed kind of a distribution plot? If you have already watched my EDA video, that will be there in the same playlist. You must be able to answer to me in the comment section. Do pause this video and answer to me just right now, right? So what I will do is I'll just do the replacement with median. I will not again do the explanation that why is that so, because I already have given the explanation a lot number of times. So what we can do is, we can do very simple thing is, we can take our data. So what I can do here is, let's go and replace that new data. And in the new data, which particular column we are referring to is building area, I believe, if I'm not wrong, right? Building area and the land size. These are the two features that I am dealing with as of now. Perfect. So what I want is, I want new data. Inside that, the building area, which I want to deal with. What I really want to do here is, I really want to replace the values of, I would say, np.nan values which are there with me. With what? With the median of this particular column that I have. So what I can do is, I can say dot median. And in this way, I will be able to get the median of the values. Similarly, what I can do here is, I can take the same kind of values for the, I would say, landing. If I'm not wrong, what's the values? Land size, right? Land size is the feature name. So I can take land size, and here what I can do is, I can just copy it everywhere. Make sense? So I have replaced the nan values of land size in the building area with the median. Let's run this. Now if I'll just again check it, new data dot is null dot, I would say, sum. So what we will be able to get is, now we will be able to get very few number of records which contains nan values. What I will do here is, I'll just, because the number of records are very low now, I'll just remove these particular values simply. Whatever be the nan values which I left with, I will remove that. So what I will do is, I'll say new data dot drop na, and I will refer in place as 2 because I want to make the original changes in the new data itself. And then if I'll just again check new data dot is na or is null dot sum, you will be able to get the value as 0 in every case, right? I hope this part is clear to everyone. So now we are having a data set which contains 0 number of nan values in each and every feature that we have, right? Now what we can do is, if you will observe here, if I'll just show you this new data dot head, the topmost 5 columns, you will observe that there are few features which are of, non-numeric type. In this case, we have to convert that into a numeric type, because whenever we are feeding our data into the model, our model will not able to understand this textual data. We have to convert this textual data into a numeric form. Now there are many ways to convert that, but here I am using one hot encoding technique, right? So how we can do that? I hope everyone is aware about one hot encoding technique. What usually happens is, for example, if suppose I will be having a column named sex, and in that we have male and female. So what will happen is, when you are applying one hot encoding technique, that sex column will be divided into 2 parts, male, female. Now, whenever male is there as the sex value as male, that value will become 1. Otherwise, female value will become 1. So there will be a 1 0 1 0 1 0 kind of a distribution which will be there, where 1 indicates that okay, sex indicates a male value, 1 0 indicates that sex indicates a female value, kind of that. Here, this is how basically one hot encoding technique works. which is basically used to transform our textual or categorical kind of a features to a numeric feature. So what I will do here, I'll just try to do this particular stuff. So I will say new data, which is equals to pd dot get underscore dummies, and here I can take the new data and I will say drop first column as true, and after that I can say new data dot head. Now here if you will see, automatically your number of columns will get increased. Can you see that? 745 number of columns we have. Why is that so? Because every particular column which contains different categories, that will be now transformed to the number of columns, right? So this is how basically we have done the one hot encoding. Now if you will observe, in this complete category that we have, the complete output we have either 0 or 1, right? We don't have any kind of a categorical data here. Now it's the right time that we will split our data into the independent features and dependent feature, or in other words, I would say the target value and the value of independent features. So what I can do is I can take the X as the input features which we have in the model, and I will use Y variable to display you the target feature that we have. Now everyone knows here what is X and what is Y. So X is something where I can simply drop the target value, which is from new data. I can do one thing. I can simply say new data dot drop, and the column is something which is equals to, I would say, price, and I want to remove column Y, so I will say X is equals to 1. See, I am not going in very much depth towards the syntax because I already have explained in the previous videos. So please, if there is someone who is coming for the very first time, and if he or she is feeling that syntax is not clear, please refer my previous videos where I have explained everything in a very bit detail. I will not repeat the same content again and again. It will be not helpful for those who are already listening the videos, right? So now we will be having the X and we will be having the Y. Independent and dependent feature is there. Now what we can do, we can split our features into training and testing. We will split our data set, complete data, into training and testing. So what we can do, we can say from sklearn.model underscore selection. What we can do is we can import train test split, right? Train test split. And here what I can do is I'll say X train. I will be having X test. I will be having Y train. I will be having something called as Y test. And here what I can do is I can apply train test split. And here I can refer X, Y. The test size is something which I am referring as 0.3. And here I am taking a random state as equals to 2. Done? So this is how basically we have splitted our data into training and testing. Now if suppose I will apply normal linear regression model. So here if you will observe, what we have done is we have splitting the data into train and test set. Now here if you will observe, I have not done a complete EDA as well. I have just a very basic EDA part. But when you are doing the implementation, these are not the only steps. Please try to understand that here my focus is to convey to you that how the implementation of regularization methods happen, right? My focus is not to talk about EDA, but if you really want to talk about that, you just have to watch that video. But here I have just skipped various steps which are very much important whenever we are doing EDA. For example, checking of the correlation coefficient values. For example, checking of the outliers and dealing with that. So all those things I have just skipped it as of now, right? Okay, moving ahead. Now what I'm doing is I'm saying that as of now, I am applying data modeling with respect to the normal linear regression model where I am not using any kind of a regularization method, right? So linear regression model, just try to apply and let's see what the results that we are getting. Then only we will be able to observe that whether we will be able to get an improvement on top of that or not, right? So what we can do is we can just try to call our model from sklearn.linear underscore model. We can import something called as linear regression. And here what we can say is we can say model is equals to linear regression. Now what I can do is I can fit my model on the training data. So I can say X underscore train and Y underscore train, right? Now, once the model is trained, what I can do is I can, check the score of my model on the test set. So I will say X test and the Y test. If I will be able to check the score now, I will be able to get the result as 14.82%. Now I will just check the score in the training set. So X train and the Y train. Okay, perfect. This is something which I have talked about in the previous sessions as overfitting. This is a very great example which I really want to show you via implementation as well. Can you see that on the training part, I am getting a very good kind of a score, which is 68.26%. But at the testing part, my score is very, very low. How is this happening? What's the major cause for that? The major cause is overfitting. Now the question is how we can avoid that. We already have learned. We can avoid via lasso, via ridge, via L1, via L2, right? So first of all, let's try to implement the regularization method as, I would say, lasso, or this is also called as L1. Now I'm doing the implementation. If you really want to check that what are the parameters which I am using here, I would suggest you guys to look for the documentation. So lasso, regularization, I would say sklearn. So if I just show you, so this is the basic documentation which I believe everyone should refer. Although I have explained about the mathematical intuition and I have explained that what is the difference between the cost function that we have in linear regression versus lasso versus ridge, right? So what I will use is, I will use this particular technique only as of now. So what I will do is, I'll call from sklearn dot, I would say, linear underscore model. What I will do is, I will import something called as lasso. And now what I will do is, I will say lasso model, which is equals to lasso, and here I will pass the parameters like alpha as 50. I'm just, randomly writing the parameter values, but there is a way called as hyperparameter optimization, with the help of which we will be able to optimize these parameters, and we will be able to find out that what is the optimal values with respect to our data set. That we will learn in the upcoming videos. So as of now, I'm just writing maximum iteration can be 100 and TOL is something which is equals to 0.1. Now what I can do is, I'll try to fit my model on the, again, training set. Same thing I'll do here, X train and Y train. And now what I can do is, I'll try to fit this, I'll try to check this score on the, again, test set, X test, Y test. And similar thing I'll do on the train set. So I'll say X train and Y train. Now here, if you will observe, can you see the difference? The previous model via which we have done, which is the linear regression, we have faced the issue of problem of overfitting, right? When we have trained our model via normal linear regression. But when I changed my model from linear regression to, lasso regression, what you have observed is, you will be able to get now equally similar values in the training and the testing score. That's where the need of regularization methods came into picture. Now I hope whatever words I have talked about in the previous video while saying the explanation part, making much more sense in this video, right? Now let's try to understand the another remaining technique that I really want to talk about is regularization method, which is the ridge regularization, right? Ridge regularization, which is also famous by the name of L2, right? Now let's talk about this as well. Lasso regularization. I'll share this coding file with everyone so that you can try on top of that the EDA part and all those stuffs. And you can also check at your home that whether the things which I am talking about here is working at your end as well or not. Okay. Now let's move ahead and let's talk about the ridge regression. So the same thing, just you need to import the different model here. So ridge you have to import, right? Ridge. And instead of, I should say lasso model, I'll say ridge model, and I'll call this ridge regression only, right? Same parameters. Now my model name will get changed, so I'll just use that name. And now what I will do is I'll just try to find out the score on again the test set and the, I would say, train set. So again, if you will observe here also, it clearly seems to us that, you know, the training and the testing score that we are getting here is approximately similar. It's more similar, right? It's more similar than the lasso as well. So that's where the need of these regularization techniques came into picture. The only thing which we have observed, or the difference that we have observed, that how our this lasso ridge regression will be able to avoid the overfitting is by adding that penalty factor in the coefficients. In the lasso, it is taking the absolute value. In ridge, it is taking the square of that slopes. And that's the major reason that why lasso is also useful for the feature selection part, but not ridge is not useful for that aspect. So all these are the things that I really want to talk about in this video. I hope that now you will be clearly able to make a difference that, you know, why these regularization techniques plays a very important role whenever there is a overfitting in the model happened. As you can see clearly this example where I have shown you that how with the help of by applying that normal linear regression model, we faced overfitting, and how we can avoid that by using the lasso and the ridge. In order to see the more part of the parameters with respect to the lasso and the ridge, I would suggest everyone to go with the documentation. With respect to any of the model, I will always suggest everyone in machine learning, whenever you are applying any sort of model, or even in the deep learning, whenever you are learning something new, the documentation is something which is a very good way to learn about anything. People usually ask me what's the very good book which I should refer or that stuff, but I didn't find anything much better than reading the documentation. Sometimes it might feel bored, but I believe if you will just sit for a while and you will just focus on the documentation part, you will be able to get a very clear understanding of the concept, right? I hope that this video was useful for everyone. I'll see you all very soon in the next upcoming video, where now we will talk about further new algorithms of machine learning. I hope that you enjoying this playlist as well. With this, happy learning to all. Bye bye everyone, and I'll see you all very soon in the next upcoming videos. Till then, please do share this video with everyone whosoever is looking for this kind of a content. Do subscribe to my channel. It will really mean a lot to me. And with this, bye bye, take care.